Relationship between velocity, frequency, and wavelength. So velocity is defined the distance traveled by the wave in 1 second. The unit of velocity is meter per second. And the frequency is the number of waves passing through a point in 1 second. And the unit of frequency is hertz. While the wavelength, the distance moved between the two successive crusts or the trough of a wave. So that is called the wavelength. The unit of wavelength is meter. The relationship between velocity, frequency, and a wavelength, the velocity is equal to frequency multiply wavelength. We can represent by the given formula. So velocity is equal to product of frequency and wavelength, that is represented by lambda, that's a Greek letter. Unit of velocity is meter per second, while unit of frequency is hertz, and the unit of the wavelength is meter. We can modify this formula according to our requirement. For example, the frequency is equal to velocity over lambda, while the lambda is equal to velocity over frequency. We can solve the question related to the product of frequency and the wavelength is equal to the velocity. Second question might possible, which row is not correct for the wave on the surface of water? Now, quantity in first column, it should match with the second column. The amplitude has a unit meter, it is correct. The frequency has a unit hertz, it is correct. While the speed has a unit meter per second. Here, the wavelength has a unit meter, while the lambda is a symbol of the wavelength. So here, the unit of wavelength is meter. So that's why C is incorrect statement. What is the number of wave front per second that pass a fixed point? So if the number of the front, they are passing through a fixed point per second, what is called that statement? So B is our correct answer here, the frequency of the wave. The diagram shows a wave. Which label distant is the wavelength? Here, so the distance between two consecutive crust or the trough, or distance between two corresponding crust and trough, that is wavelength. So here, for example, the distance between these 2 points, half consists of crust and half is trough. That's making one wave, that is wavelength. Which row correctly indicates the amplitude and wavelength of the wave? Now, amplitude is a maximum distance away from the mean position. For example, the distance between 2 and 1, that is amplitude. Well, the distance between 4 and the 6, these are two corresponding points. Between 4 and 5, this is trough. And between 5 and 6, this is crust. And when the one crust and one trough join together, it's making one wave. So the correct option will be here, that is B. The distance between 1 and 2 is amplitude. And distance between 4 and 6 is a wavelength. A boy throws a small stone into a pond. The waves spread out from where the stone hit to the water and traveled to the side of the pond. The boy noticed that 8 waves reaches to the side of the pond in the time of 5 seconds. What is frequency of the waves? Here, the two values are important, number of waves, and the total time is given in 5 seconds. So we can calculate the frequency by the formula, the number of the wave passing through a point in a total time. For example, the total number of waves are 8 per 5 seconds. So here, if the 8 waves are passing in a 5 second, so in 1 second, how many waves will pass through a certain point? And that is 1.6 wave will pass in 1 second. So frequency will be C. Here, 1.6 hertz is our correct option. Sound waves of the frequency 2 kilohertz travel through a substance at a speed of 800 meter per second. What is the wavelength of the waves? Now here, with the velocity, you can see the speed unit is meter per second. So that's why we can represent the hertz in a unit form. So that's why this kilohertz will be converted into a hertz by multiplying 1000. So here the relationship, according to the given formula, is the lambda is equal to V over F. Now here, the velocity is 800 meter per second, while the frequency is 2000 hertz. So here, the speed S will cut with the hertz, and the 8,000 divided by 2,000, that will produce the answer 0.4 meter. A will be our correct answer. A student writes down some fact about the two transverse waves. So wave produced in water and wave produced in rope, these are transverse waves. The wave 1 has a frequency f and the velocity v, while the wave 2 has 4 times the frequency of wave 1, and it's traveling at a velocity of 2 times of the wave 1. So what is the wavelength of the wave 2 in terms of f and v? So we can represent the wavelength is equal to the v over f. And if we represent the wave 2, so wave 2 is a 2 times of velocity over 4 times its frequency. So we can simplify by the table 2 1s are 2, 2 2s are 4, and that will produce the v over 2f. So D will be our correct answer here. Hopefully it will be helpful for you. If you would like to ask any questions, so you can put your question in the comment box. Thank you. Thank you very much.